Right. A couple of days we were focusing on OSPF. Yesterday, we were able to do a lab from which we learned things like 7 stages, and we were seeing some show commands, and we spoke about router ID and a few more things. Today, our focus is on configuring OSPF network types. We already know there is a network type called broadcast and the point-to-point. I showed you this in the previous class. You remember when I typed the command show IP OSPF interface serial/0, it was showing network type point-to-point. That's one of the network type. And when I was typing show IP OSPF interface fast Ethernet 00, the network type was broadcast, isn't it? We already saw this too. Serial, Ethernet. Serial means point to point, Ethernet means broadcast. If it is point to point, there is no master, there is no DR/BDR, and there will be a temporary master slave relationship for that exchange of TBD. Later on, there is no more master, no more slave. Whereas on the broadcast type, there will be a DR/BDR election, and this DR state, BDR state continues even after sharing DBD. And in the point-to-point, both the neighbors will be in full state. In broadcast, only with the designated router and backup designated router, there will be full state. With the other routers, there will be only two-way state. All these are known stories, which is going to repeat here in this chapter. Apart from these two types that you have learned, see, what you have learned is important. But there is also another 5 types. Another 5 types. Apart from this 2 type, there is also another 5 types. But they are not that sensitive like this 2. Point to point, when you have a serial link. Broadcast, when you have Ethernet. Do we have any other link in the real world? Serial wire, Ethernet wire. Do you have any other wire running OSPF? No, we don't. Then what is that other 5 types that you are going to learn? Virtual wires. Virtually, we will have multiple connections over the WAN wide area network. So far, what you have seen is not over the wide area network. It is within your enterprises, 2 routers running serial, few routers running Ethernet. This is what you have seen, point to point and broadcast. These 2 network types are very common. And IGP protocol is what this OSPF. The other 5 types that you're going to learn is not within this enterprises. It is not within the enterprises. It is only if you have a WAN connection, cloud. So between this office and that office, you got a permanent virtual circuit, PVC. Only in such scenario, the other 5 types that we are going to learn can be used. What is this PVC? A virtual pipe, a virtual connection between the site. It's a tunnel. PVC means permanent virtual circuit, provided by a technology called frame relay. This frame relay is very old, ancient days protocol. According to networking, anything before 25 years is ancient only. Anything before 25 years is ancient. Karkalat protocol. Frame relay is an ancient protocol. Using which we used to have a virtual tunnel called PVC. And this frame relay environment is called as NBMA environment, non-broadcast multi-access. Here you have this, that, and there is one more called there. Multiple access, you see, 1, 2, 3, multi-access over the non-broadcast frame relay environment. In such environment, when you run OSPF between the sites, when we run OSPF between these sites, which is running frame relay, what does that mean? OSPF is going to run on top of frame relay. Then you call that OSPF as NVMA, non-broadcast multi-access environment. OSPF running on non-broadcast multi-access environment. When you run OSPF on NVMe environment, you can have 5 different network types. That is what this page explains here. This we already saw. This also we already saw. When we had serial wire, we had the network type point. When we had Ethernet wire, we had network type broadcast. If you will have any ancient protocol like this to communicate between different sites, then we call it as NBMA network. In this NBMA network type, in this NBMA network, you have 5 different OSPF network types, or 5 modes of OSPF available for NBMA network type. I want you to make a note of this one thing which I am going to tell you. This too is not on top of NBMA. This is within your organization. No frame relay involved in this. Whereas in this 5 type, 4th type is broadcast. 5th type is point to point. I do not want you to confuse with this one and this one. This one and this one is not same. This out of this 5 modes, this 4th and 5th mode name is same like what you have here, broadcast and point to point. But the environment is not same. This broadcast is on top of frame relay. This P2P, point to point, is on top of frame relay. Whereas this P2P, I showed you yesterday, HDLC. And this is over Ethernet. All right, so when I show you this 5 mode, you will see broadcast and point to point. Don't think that this 2 point is in the list. No, these two are different broadcast and point to point from this. You see, these are the 5 modes in NBMA. You see the 4th one and 5th one. This is not that. That is not this. நான் அவன் அல்ல. இந்த மாதிரி இது அது அல்ல. இவை இரண்டும் ஃப்ரேம் ரிலேக்கு மேல போயிட்டு இருக்கிற OSPFல இருக்கிற ஒரு நெட்வொர்க் டைப். ஆனால் இவை இரண்டும் அது அல்ல. இது நார்மல் சீரியல் ஒயர்ல ஏதோ ஒரு புரோட்டோகால் HDLCயோ அல்லது PPPயோ அதுக்கு மேல ஓடிட்டு இருக்கிற OSPFல இருக்கிற டைப். இது ஈத்தர்நெட்டுக்கு மேல இருக்கிற டைப். We know the difference between these two very well. That is what you learned in the previous class and the before class. But this 5 is totally new to you. You may ask, why do I need to learn? Why should I learn when this NBMA doesn't exist? These are all கற்கால புரோட்டோகால்னு சொல்லிட்டு மூத்த குடியினர் பயன்படுத்திய புரோட்டோகால்னு சொல்ற பின்னாடி இதை எதுக்கு நான் படிக்கணும்? Are we going to have this NBMA? Are we going to have this frame relay? No. Then why are we learning this 5 type? If you have that question, that's a very valid question. The reason why you're going to learn this 5 mode is, in case if you like to have one of this 5 mode in your normal Ethernet environment, you can have it. I repeat, if you want to have any one of this 5 NBMA mode in an Ethernet environment, you can have it. For example, You have Paris corner in Chennai. Why they named it as Paris corner? Maybe they want to simulate the Paris, the European city in Chennai, so that those who don't want, those who cannot go to the real Paris may go to this Paris corner and console themselves. நான் பாரிஸ்க்கு போயிட்டேன், நான் பாரிஸ்க்கு போயிட்டேன், எல்லாம் கேளுங்க, நானும் பாரிஸ்க்கு போயிட்டேன், அந்த மாதிரி. இந்த என்பிஎம்ஏ மோட்ல இருக்கிற 5 மோடும் ஒவ்வொன்றும் ஒவ்வொரு மாதிரி செயல்படுறத பார்க்க போறோம். அதுல ஏதாவது உங்களுக்கு பிடிச்சு போய், அடாடா இது ஈத்தர்நெட் என்விரான்மெண்ட்ல இருந்தா நல்லா இருக்குமே அப்படின்னு தோணுச்சுன்னா நீங்க அதை பயன்படுத்திக்கலாம். அதுக்காக தான் இந்த 5 மோடு படிக்கிறது. Even though you are not working on an NVMe environment, if you wish to have one of this mode in an Ethernet environment, you may have it. You can have it. For that, you should know this 5 mode, how they behave, so that if you like one of this mode's behavior and want to have it in an Ethernet environment, you can have it. That is why we are going to learn this. I have now told you the reason why we are going to learn this 5 mode. Even though we don't have frame relay, ATM, X.25, which are all very old layer 2 protocols. Now popular is what? Ethernet only. Ethernet and serial, point to point. These token ring, frame relay, ATM, X.25, who knows? People like me know, but why do we know? There's no use of we knowing it, because I don't see anywhere frame relay. Tata Teleservice in Hyderabad, when I visited in the year of 2013, they were having frame relay, but in a very small portion only they had. Most of the portion they moved to MPLS. This is 2024, almost 10 years already passed. I don't think even Tata Teleservice in India, which is a very old telephonic company, the oldest telephonic company in India, Tata, I don't think even they will have frame relay now. It was there in 2013, but in a small portion. So why are we learning? As I said, these 5 modes functions are not same. That's why they are 5 modes. 5 modes are going to behave in 5 different ways. When you know these behaviors, if you like one of them to have an Ethernet environment, you can have it. That's why we are going to learn. Do anyone have got any question on these, what you are going to learn? You see, this is normal point to point. This is not over frame relay. Routers are connected using serial interfaces. If it is Cisco router, by default HDLC will be the layer 2 protocol. You can also change it to PPP. Let me show you how to change the serial wires. You got serial between R1 and R2, and let me show you. Show interface serial /0. If you notice here, the encapsulation type will be HDLC. That is what the presentation was talking about. This is the default layer 2 protocol. Instead of this, you can also have PPP, point-to-point protocol. But you need to enable the PPP on both the sides. These two are Cisco routers, so by default, HDLC on this end, HDLC on this end. No confusion. They will form, they will talk each other, they will understand each other. But if you will have a Cisco switch, Cisco router and a non-Cisco router, then you need to worry about this encapsulation. If this is Cisco and this one is Juniper, this will speak in Telugu, this will speak in Urdu. They don't understand each other. This is speaking in Urdu, HDLC, and this is speaking in Telugu, PPP. They don't understand anything. So you have to go to Cisco router, which supports both HDLC and PPP. Change the Urdu to PPP. Change that HDLC to. Only then they will talk. Now let me show you how to change it. I'm an R1 interface serial 4/0. This simple it is. Encapsulation PPP. That's it. See, it is going down because the other end is HDLC. So go to the other end also. Interface serial 4/0 encapsulation PPP. Now the interface which went down will come back again. See, it has come back again. If you go back to R1, you will see it is up again. Now let's go and check the same show command. Show interface serial 4/0. The encapsulation now should be right. These are all protocols, different protocol. The way they interact is different. That's why the name is also different. This is PPP, that is HDLC. Now, what is next? Let's go back to our finish. You see the first line? Usually the serial interface running either PPP or HDLC. May also be a point-to-point sub-interface running frame relay or ATM. See? Let me show you that also. If I wish to run frame, in case, instead of this router, if I have a frame relay here, then I should run frame relay in the center, isn't it? How to run? Interface serial 4/0 encapsulation frame relay. You see? Encapsulation frame. See how many types? Start 2.5. These are very old types. Very old types. Frame relay is also old. You may also have a sub-interface. Sub-interface is what? Taking one physical interface and subdividing into multiple logical interfaces. There also you can run this frame relay and ATM if you wish to. Whatever, whether it is frame relay point to point or a normal point to point, serial point to point. In point to point, there won't be DR and VDR. I repeat, in point to point, no DR, no VDR. Why? Because it is just point to point, two members. Two members, just two members. Now, you remember yesterday when I was showing you the network type, under the serial interface, it was showing network type as point to point. Did I configure it? No. It was auto-detected. OSPF auto-detects its interface type. If the interface type is serial, then network type is going to be point to point. OSPF packets are sent using multicast address 224005 only. There is no 224006 needed because it is just two router. Point to point is two router. There is no need of that another multicast address which is used in a broadcast multi-point environment. Only in a multi-access broadcast network environment, in order to talk to the DR, you need .6. For DR to talk to every other router, you need .5. Because in broadcast multi-access environment, there is always BDR and DRL action. And every router will form full adjacency with the DR and BDR only. So in an Ethernet environment, forget about token ring. This even in ancient days we did not use it. Just it was there for few period, very less period, vanished. So in a LAN technology, which is on and only Ethernet today, you will always find DR, BDR. So there will be two addresses. In order to talk to DRs, .6. In order to talk to others, .5. As I said earlier, the election process, first preference is given to priority. The default priority is 1. If all routers have got same priority, then there is a tie. The tiebreaker will be the router ID. The router with the highest IP address becomes the router ID. Sorry, becomes the DR. The routers whose router ID is big, the big IP address, becomes the DR. And second biggest becomes the BDR. But when there is a priority set like this, then the highest priority router is selected as DR, and the second highest will become a BDR. If there will be any router with a priority 0, this will never participate in election. This will not participate in election. This will remain DR other always. This will remain DR other always. It will not participate in election. சில பேர் பாருங்க உலகத்துல பெருசா பற்றே இல்லாம இருப்பாங்க. அவங்க நினைச்ச எம்எல்ஏ ஆகலாம், எம்பி ஆகலாம், பிரைம் மினிஸ்டர் ஆகலாம். நான் உலகத்துல பற்று இல்லாதனால எதுலயும் பார்ட்டிசிபேட் பண்ண மாட்டாங்க, கண்டுக்காம இருப்பாங்க. இந்த உலகத்தை எப்படியாவது நான் ஜெயிச்சு நல்ல ஒரு ஓட்டத்தை ஓடி இந்த வாழ்க்கையில சூப்பரா ஜெயிச்சு முடிச்சா போதும்டா, தொல்லலாம் வேணாம் நமக்கு. அப்புறம் எதுலயும் தலையிடாம முடிஞ்ச அளவுக்கு பார்த்தும் பார்க்காம கேட்டும் கேட்காம எல்லாத்தையும் இக்னோர் பண்ணிட்டு அப்படியே ஓடிட்டு இருப்பாங்க. அவங்க தான் புத்திசாலிகள். That is what this router is about. See, why we need தொல்லை இல்லாம இருந்துடலாமே. Priority 0. It will never participate in election. It will remain dear other always. Fine. The last point. This point I explained to you yesterday. Once DR and BDR is elected, after that, whatever the superior hello packet come, what is superior hello packet? The hello packet with priority 10. Priority 3 is the DR here. But if a router comes with a hello packet priority 10, can A become DR? No, it cannot. Why? Because OSPF is non-preemptive. OSPF is non-preemptive. So A cannot become a designated router. It is non-preemptive. DR election is non-preemptive. If A wants to become a DR, what is the procedure? Restart all the routers. So re-election is going to happen. Everyone will now start everything from the beginning. The election will start again. Then A has got a chance. Is there any other way? Yes, there is one way. What is that? Shut down this device. If you shut down this device, BDR will promote as DR. This will promote itself as a DR. Now election will be between these two. This guy says, I will not participate. It goes like that. C will not participate. So these two are now competing. This guy says, okay, I will be a BDR now. Now this poor guy is coming back again. ஒரு காலத்துல நல்லா வாழ்ந்த குடும்பங்க அந்த மாதிரி வருது. DR is coming back again. But the problem is, because there is DR and BDR already, this cannot become a DR or BDR. It will go as DR other only. Fine. Now this DR is dead. What will happen? This will be promoted as DR. See, now only it gets a chance to become a DR. And now the election will be between these two guys. And this guy says, I am having priority 3, so I will be a what? BDR. I'll become BDR. That's it. You see? This is how the non-preemptive election process works. If you wish to set priority, this is the command. I remember when I did the lab, I used this command in the notepad. IP OSPF priority, and then I gave a number. I told you, no, if the priority is 0, it means it cannot be, it won't participate in election. DR posting BR posting election cannot be a DR BDR. The router won't participate in election. Simple. That's my version of saying this. The priority can be any number between 0 to 255. The default is 1. The router which is not a DR or BDR, they are called as DR other. Okay. You see, this one explains what is NBMA. Between this 4 site, see these 4 are not in 4, they are not in same location, they are in 4 different locations. This is one location. Maybe this may be Pune. This may be Jaipur. This may be Hyderabad. This may be Kanjivaram. You see 4 different locations. In between to connect, you have this frame, which is nothing but NBMA environment. Frame relay is an NBMA environment. What does NBMA means? Non-broadcast multi-access environment. This also means what? Without broadcasting capability. Broadcast is not supported here. Multicast is supported, unicast is supported, but broadcast is not at all supported. Full of routers. This is not a switch to support broadcast. What do you have in the internet? Full routers everywhere. Will router allow the broadcast to pass through? No. But I want to connect this 4 like I connect via a switch. The cloud is non-broadcast. Using that non-broadcast, I want to create a broadcast environment. See, we call this as underlay and overlay. Underlay is without broadcast capability. Without broadcast capability. Underlay. We call it as non-broadcast multi-access. That is underlay. What is overlay here? Frame relay. What does frame relay provides? With broadcasting capability. Underlay, overlay. See, what is this underlay, overlay? Underlay is physical wire, physical network. Overlay is a tunnel that you create. If you go to some cities, you will see underlay. Means normal road with too much of traffic and lot of signals. But there is also overlay like frame relay. You take the one small 60 rupees token, you fly over the bridge, no stopping for 5 kilometers or 8 kilometers or 10 kilometers or 12 kilometers. You don't need to stop. You just fly on top. That is overlay. Overlay is also in the same city. Underlay is also in the same city, same map, everything is same. Only difference is இது கீழே அது மேலே. Only difference is this is underlay, that is overlay. Underlay, you have to stop for every signal and you have to maintain the lane disciplines. Overlay, it's yours, all free. For next 10 kilometer, if you climb that bridge, no need to worry. That is what called as overlay. Now, if the overlay is built using one of this technology, frame relay or X.25 or ATM, then these 5 modes which you are going to learn next is applicable. These 5 modes. 2 on the top, 3 on the bottom, you see, these 5 modes. For the overlay which is made out of these 3, any one of these 3. If your overlay is made out of any one of these 3, then these 5 modes you can have one of this. But nowadays we don't have this 3. Instead what we have is MPLS. Instead of this, what we have is multi-protocol label switching VPNs. VPNs using MPLS. This is very cheaper and faster comparatively. All right. So we are not going to learn frame relay here. We are not going to learn frame relay, but I will be using frame relay to simulate this NBMA environment to teach you these 5 modes. Yeah, I'll be using frame relay. I will also explain you here and there frame relay if you can understand. Good. But where will you use it? I don't know. Okay. So NBMA topology supports multiple router without broadcasting capabilities. DR election in NBMA topology. OSPF considers NBMA to be like other broadcast media. The DR and BDR need to have full mesh connectivity with all other routers, but NBMA are not always full meshed. The DR BDR needs a list of neighbors. OSPF neighbors are not automatically discovered by the router. Okay. These points I don't know whether you understood or not, but I'm going to explain you. And if you will have question, you ask me. You see, when I have a router and I have some routers connected through a normal switch, so there will be one DR router and one BDR router. We all know this. But the problem is, even though you don't have a Ethernet, you have frame relay. Frame relay will not work on Ethernet wire. It will work only on serial wire. That's why I'm drawing a zigzag wire, zigzag line. You have frame relay. Even in frame relay environment, the DR-BDR election happens. But there's a problem in this. What is the problem? If this is fully meshed, what is full meshed? If R1 has got a connection to R2, R3, R4, R5, and R3 to R2, R3 to R5, R3 to R4, R5 to R4, R5 to R2, R5 to R1, R4 to R2. If it is like this, we count as full mesh. Everyone need to be connected to all other routers. Then it is full mesh, then DR-BDR is good. But in the real world, NVMe networks are not always fully meshed. What does that mean? Most of the time, NVMe networks are hub and spoke. If this is hub, it will connect to all spokes. That's all. There won't be connection between this and 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 this. No. Why? Because it is frame relay. You have to pay a lot of money for each frame relay connection. Very costly. If I want to talk to beta from alpha, from omega, sorry, gamma. This is gamma. If I want to talk from gamma to beta, instead of having one connection here, what we do is, to save money, we go to hub, and from hub we go to beta. Why? Because frame relay is costly. When we already have a connection with the hub, let's go by hub. So in the real world, no one is ready to have full mesh. Full mesh is costly. In that case, this DR is useless. Why? If this link goes down, all this will break. What is the use? What is the use of this DR and BDR? No use. There is no use. So, if it is full mesh, then useful. If it is full mesh, even if this link goes down, no problem. There is still connectivity with 2, 3, and 4. There is some useful in the role of DR and BDR. But in hub and spoke, it is useless. That is what this page explains you. Most of the time in the real world, it is only hub and spoke. So the DR BDR needs list of neighbors. You don't have all neighbors. You have just got Uh, OSPF neighbors are not automatically discovered also. Yeah, this is very important point. I'll be emphasizing on this in next class. Neighbors are not automatically discovered. But I want you to be comfortable with these 2 points. OSPF thinks that NBMA is also like a broadcast media, like which I draw with the switch. And it starts running an election, DRBDR. But DRBDR needs full mesh. But in the real world, not every NBMA is full mesh. So that DRBDR is useless. We need to do something for that. Not only that, the neighbors need to be manually configured. They are not automatically discovered. We'll discuss on all these matters in our next class. All right. So you see, this explains what full mesh means. All connected to all. This is what mostly you see, hub and spoke or startup also. Sometimes some people may have partially full mesh and partially hub and spoke. We call this partial mesh. All right. So we'll continue this. From here only we start the important story. To understand these 5 points, we had this all foundation done. We'll 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 continue this tomorrow. Any questions so far? No questions?